Hello, welcome to ChemE Help. Today we're going to talk about material balances, and material and energy balances are the foundation for all of chemical engineering. So it is very important to get some basic understanding of material balances. And so at the beginning, we're just going to be talking about steady state, and for steady state material balances, the mass flow rate in is going to equal the mass flow rate out. And that's just coming from conservation of mass. And so that is going to be the basis for this entire problem here, is that the mass of the whole system and the mass of a single element will always remain the same. So for this problem here, it says stream 1 enters the column comprised of 40% A and the rest B. There are two exit streams. The top exit stream is 90% A. 50% of A exits from the bottom. What is the composition of the bottom exit stream? So the first thing that we need to do is we need to draw it out because it will help us visualize. I know this is a basic one, but the more often we do the drawing out, the more it will be ingrained in our head to be drawing it out each time. So there's a stream that enters, stream 1, and it has 40% A, and then it would be 60% B. We have two exit streams. On the top, we have a stream that is 90% A, right? So that's 90% A, and that would mean that there's 10% B. And then we have a stream on the bottom. And that is, it says that 50% of A exits on the bottom, but you're looking for the composition of the bottom. So we do not know that yet. So in order to figure that out, we set up a material balance. So you can start with an overall material balance. And so your overall material balance is that M1 is equal to M2 plus M3. So I'm just saying this is the first stream, right? So this M1, right, what goes in must come out, basically. And the same is going to be true for A. So I can set up an A balance, and that is that M1A is equal to M2A plus M3A. And so, and that these can be written differently. M2A is the same as saying X, or the mass fraction of A times M2. So with this, we know that in a specification given, so specification of the system says that 50% of A exits from the bottom. That means that M3A is equal to 50% of M1A. And so that is equal to 50% of 40% of M1. So we don't actually know M1, it's not given, but what we do in these situations is we set a basis. That means we just assume that M1 is an easy number, like 100 kilograms per second. So we can say M1 is equal to 100 kilograms per second. And then we can solve for this, and we get that M3A is equal to 20 kilograms per second. Okay, and so because M3A is 20 kilograms per second, and we know M1A there, we can solve for M2 using this A balance. Okay, I'm going to substitute this in right there. And so I'm going to get that, so you see that M1A is equal to X A in stream 2 times M2, and then plus M3A. Okay, so this will be 40 kilograms per second is equal to, this XA2 is 90%. It is given right here in the problem statement. So that is 0.9 times M2 plus 20 kilograms per second. That means M2 is equal to 22.22 kilograms per second. So that is the amount of A and B up in this top one right here. So with that, and using our overall material balance, we can say that M3 would just have to be 100 kilograms per second minus 22.22 kilograms per second, which is 77.78 kilograms per second. Okay, now the problem statement isn't asking for the amount. It doesn't even give us an amount, so it wouldn't make sense. It's asking for a composition at the bottom. So you got to keep that in mind when you're doing this stuff. So in order to get that composition, we can put it back in to the equation, one of these equations like that. So you see that M3 times X3A is equal to M3A. Okay, so we have M3 now, right? That's right here. We have M3A, which is somewhere. We used it here. There you go. And so X3A is equal to 20 kilograms per second divided by 77.78 kilograms per second, which is equal to 0.257, which means that X3B is equal to 1 minus 0.257, which is equal to 0.743. And this right here, that is your answer. That's what it's asking for, the composition on the bottom. So anyway, thank you guys for watching. Please leave a like and subscribe for more videos.